So how's weekend going so far?
Not bad, Hemant.
Not bad. All right. Not too much work, I suppose.
No, no, no. Actually, this week, I was assigned to write test cases, JUnit test cases for others code. It's a hell.
Oh man. So are you becoming more like a test engineer now? What's the
Actually, like during the release, right? So we didn't do our DOD, means like the definition of done. So there's a lot of test cases left. So this sprint is all about complete technical debt. So as a part of this, I was assigned to write, that GUnit test cases for all, APIs and all those stuffs. So,
Oh, okay.
so yeah,
Yeah.
very hard to write, a test, like test cases for others code, because you need to understand their code.
Yeah, that's true. Uh End to end or just unit tests?
Unit test.
Unit tests, yeah. Unit tests are harder. End to end are easier a little bit, I think. Because you don't have to do setup and everything. So, yeah. Yeah, I'm also doing some at work. I'm responsible now. So we are moving to this mobile app using React Native, and my manager um, gave me some work. Saying she said, "Okay, can you figure out how to test this application?" We haven't started develop. I mean, we just started developing. We haven't done much, and testing React Native is a little bit difficult because it's a mobile app, but you write it in React. So I had to. There's a framework called Jest and Enzyme, and so I'm looking into that. It's interesting, but yeah, when it comes to writing it, I'm just gonna delegate to somebody else, hopefully. Otherwise, once I figure it out, my manager would be like, "Yeah, can you do this?" So I said I told her that okay, can you assign somebody who would do this? But it's a lot of learning. I think when you understand the test, you understand some of the internals of it. So it's important to learn testing nowadays because in old days there used to be like a separate department who do the QA. But I think nowadays more and more companies are actually saying that we don't want to spend money on QA. So they ask a developer to do the QA, and mostly rely on automation testing, right? And that puts a little bit more burden on developers. I would say.
All of us, right, to be on a QA hat.
Yeah, I know. Which I think sometimes is a bad idea because if a developer does a QA, then he will let a lot of things go, right? Because QA has a specific mind of they're not gonna let things go easily. Developers are like, okay, yeah, this bug is fine. Yeah, that's an issue. But yeah, so I think yeah, Rama is here. So let's just get started. Um, so today what we're gonna do is I know last week we had a little bit of a uh, mix up. So yeah, this class will be Saturday. I think I tried to set up the calendar, but somehow it did not go through for Saturday last time. And the go to meeting account that I had uh, purchased had expired, so I purchased it again, and so this is a new account, and then so always refer to the the code from the URL from the invitation from the calendar. So hopefully everybody, I know some of you actually accepted it, so you can if for URL just go there, and if there is a change in URL, I will let you know in advance so that. But the class will be every Saturday around 8:30 p.m. Pacific Standard Time. Okay. All right. So um, let's just get started on, since it's been almost 2 weeks. Today we're gonna do object-oriented programming in JavaScript. Um, so now, object-oriented programming in JavaScript is a technically kind of mix of object-oriented and functional programming. It's more functional than object-oriented, and more programming languages are going functional way. Um, that because object-oriented programming is quite difficult, not in the sense like programming wise, but in order to um, extend your application. So let's say you build an application where you have a specific uh, tree of inheritance, right? And then suddenly something new comes in. Now you have to break the entire tree because you cannot fit this new item in the tree somehow. So that's why it's very difficult. A lot of things are going the mix-in ways. You probably heard of a lot of mix-ins, right? Mix-ins are basically you grab functionality from here and one class or one object, and use functionality from another object and mix them together, and you get a new object with that inherits property of both. Okay, so a lot of things are going that way also. And overall, I think JavaScript is functional programming language. But if you notice, um, underneath it's still using a lot of um, object-oriented stuff that you don't see. And I think it's important to understand for two reasons. One is when you're writing pure JavaScript, you should be able to understand what's going on, right? That's the first thing. And now they have classes in JavaScript, right? Since ES6, and the way they are using classes, if you look at it, if you worked on React or Angular, now they're using classes. So inheriting the main package. So let's say if you have an Angular package, the core, you can inherit using create your own class by extending that package, and then you write the functionality within it. So um, you are using it, and also underneath it's doing the prototype inheritance. Now the difference between prototype inheritance and what is considered as a classical inheritance. Java, I would consider as a classical inheritance, though it has changed quite a bit, right? Um, since initial version, I should say. But JavaScript has defined completely different model called prototype inheritance. The difference also is in Java, you have classes. Even though JavaScript has classes, they're not like real classes like Java. Underneath, they're doing the same thing, prototype inheritance. So we're going to look at that as well. So if you want to start with understanding the inheritance, the first thing you need to understand is a constructor. So every function is a constructor in JavaScript. So remember, if I write a function, let's say const add.
I cannot see a screen.
Oh, you cannot see. Oh, actually, I forgot to share.
Also recording it?
Yes, I'm recording it. Yes. Okay. So let's say I have a function. Can everybody see my screen?
Yes.
Okay. All right. So let's say you have a function called add, right? And you can, we're just gonna use arrow function. You can, if I pass A and B, and usually there is some sort of return, right, which does A plus B. This is considered as sort of like a pure function. What pure function does is it takes two arguments, or it takes some arguments, and it returns something using only the things that you passed to it, right? Here, if I did something like this, for example, if I have a C here, and if I do this, then this function becomes confusing because its result is not going to be predictable every time, because now it depends on C here. Let's say if I have C here equal to 1 or something, right? Now it depends on some outside state that affecting its inside state, right? So pure functions are the functions that that take some argument, does some processing on it, and returns some results, and it doesn't use anything from the outside scope. Okay. Constructor, on the other hand, let's say I can create, and I would suggest if you use a constructor, use a capital. Let's say if I have a constructor called car. Okay. Another thing with the constructor is try to use a regular function, and I'll tell you why in a minute. Okay. Now it can have arguments. I can have car, let's say model or something, right? But the objective of the constructor is to produce objects. So it could return something, but the objective is not to return anything. So the way it would do is I can simply say this dot model equal to model. All right. Now this one I should do something like this so that it's not confusing. Here I'm not doing anything, I'm not returning anything, and I'm just saying this dot model equal to model. Okay. Now, what is this inside here? That is why I'm using function, because I want car to have its own this. Inside here, remember when we learned that arrow function doesn't have their own this. It just uses this of the outside environment. That's why all the pure functions you can use arrow functions. However, if you have a constructor, you want to have your own this. That's why you would use a regular function. Okay. Now, the add function, you would execute something like this, right? Constructor, you would use if you use the like this, it's meaningless. Let's say if I say Toyota, right? This is meaningless because let's see what happens. In add function, it basically returns adds these two numbers and returns. So we'll get 3 right here if I console log it here. For the car, if I set, it says this dot model equal to model. So it sets this dot model to Toyota, but that's about it. It doesn't do anything. So let's run this, see what happens. So if I run this, well, let's try to console log here. So the first you get 3. The second one you get undefined because I'm not returning anything. If I try to, let's say, console log this inside here, it gives me Windows. Even though it has its own this, because I'm running as a regular function, it gives me as Windows. Okay, so the true use of constructor is not to call it directly like this. Instead, you should always use new keyword. So I can create a car called let's say const my car equal to car Toyota. So what happens here is that it takes this car constructor.
Should it be a new car?
Oh, sorry, my bad. Yeah, a new car. What it does is it takes this car and it sets a model equal to model. So this would give me a literal object literal. Okay, so now if I do, let's just remove this thing. If I do console log my car, I would get a car with a model Toyota. Okay, so this is how constructor works. Now,
that returns an object literal. What's the difference between a regular object and an object literal?
So the object literal is if I, okay, so there are two kind of objects, right? Object literal means if I do, let's say, if I have an X, some property, okay, this is an object literal, right? And object so constructor, so this is an object also. Function in JavaScript, as I said, there are a lot of objects, right? Different kinds of objects. Object literal is now this, if I simply look at this one, right? It's a model, and so in a nutshell, if I do, let's say, JSON dot, I think it's a stringify. Okay. So if I stringify this object, it will give me something like this, right? So this is an object literal. This is called object constructor. Okay, functions are also objects. The difference between also is that here this constructor actually produces an object, which is an object literal, right? And if you notice that if I, so JSON.stringify, it basically takes the object and it converts into a string. Okay. But if you look at this object, it has a property by default called underscore underscore proto underscore underscore, right? Now this is, we looked at last time, but I think now we should look at more in detail what exactly happening here. Also, the car would have similar prototype, but it would have a different. So let's understand what's happening here. So proto underscore underscore proto, think of this as its creator. So this is where you created a car, okay? And if you look at its creator has a constructor which is holding the information inside. You can see the car inside here. So we know that who created this object. Okay, so car created this object. What else it has? Now, because it's a constructor, it also has its prototype, because constructors are functions, right? So function would have its own prototype, and you can look at it, it has all the function related methods, right? Apply, call, bind, all that stuff. All right, so if you want to understand the proto, you need to open the tree. So think of this way. Constructor car created my car. So my car should have a proto which should have a constructor of car, and everything is created from this master constructor called object. Okay, so if I to understand it a little bit more, let me do one thing. So if I just have a regular console.log, so I have another object literal, okay, here. So let's understand. Well, so here if I just do log, it won't work. I have to say dir. Okay, so here you can see the first one, my car. It's a type of a car, so that's why it shows a car. Here it just shows an object, because this every object in JavaScript, it's created using this master constructor called object. Okay, that's its like ultimate. Think of like a god in a concept, right? You can say, I created the car. Toyota created. I mean, this company created what created the trees and everything. God created the trees, right? If you believe in a god or not, that's a different story. But think of in JavaScript, everything is created using this master constructor. Okay, so when I created this A1, because I did not use any constructor, it uses the default constructor, which is object. That's why you see this. Its proto is object. As you can see, it has one of the properties is has own property. Now, if I look at the car constructor, car is created using the my car is created using the constructor car. So that's why you see this constructor in between, and then ultimately you would see the same thing here, has own property. So the difference between this two is the one more layer in between. So this object is created directly using object, the master object. My car is created using the car constructor, which is created using the master object. Everybody got it? This is very important. Yeah, go ahead.
I understood, Hemel. In the car one, we have another proto which belongs to car constant. So if we do car.prototype.something else, we would see when we do console.log my car, isn't it?
So prototype is different. So this is just a proto. Again, a lot of people are confused, and when I started learning the concept, I was also very confused. So I would suggest, think of, that's why I want to go slow on this one, because If you master this, then you would understand the prototype inheritance very beautifully. So underscore underscore proto is, think of it as a creator, right, of this object. Okay. Um, if I do dot prototype of something, it's different. But we're gonna look at that later on. Uh, the way to find out who's the creator also, you can simply do, let's say, my car dot proto. If I do this, I can access it. So instead of my car, if I do this, right, then it would give me, let me clean this up. Then what it would give me? It would give me the constructor itself. If I want to go further, I would just do again and run it. Now it gave me the final constructor, right? If I do now further down, I get null. Well, let me just remove this because otherwise it's confusing. Because it's almost like a who created guard. Nobody did. Nobody knows who created guard, right? So this takes me to a point where everything ends. So nobody, it's almost like nobody created guard. Okay. So that's how it works.
So after two protos, we should see object, right? If you just do my car dot proto, should we see object?
Yeah, we should see object. Yeah.
Maybe one more.
Yeah, this is object, right? Yeah.
Cool.
But yeah, the way you see, the object is you would see this has own property, right? So if I console log this guy, because you won't say object, but you would see this here. So here in its proto, you have this has its own object is prototype off. You see the same, because this is coming from the master object. Okay. And the funny thing is this, right? When you see, when I do proto, it doesn't give you the name of what it is, but it just gives you the method. But you can recognize it by looking at its method. What object is this, right? But yeah, I think it's very important, and always practice. Just go and create some objects and look through the tree to understand it, what's going on. Now, same thing if I do for this, what we did for my object, right? Now let's do for car. I'm just gonna do this. So okay. So as you can see, my car was created using car. That's why the first one. But car is created using this f. What is f? F is a function. So function, because it is a function, right? Constructor is a function. That's why you would see it's, and function has its, and now that the prototype comes in the picture, you see this prototype. So prototype here means anything that you have, and you can see it just keeps going in chain, because anything that you apply to it, so any method that you add goes into its prototype. Also, another thing you need to notice is that, because when you have a function, you have a, this is a new thing that they added, and Chrome keep changing it. It will have scope, and it would have, if you have closures, you would see it here as well. Okay, so they have actually captured the whole global inside here. This is almost like a, I remember, if you, so with every object, they are actually capturing the entire global so that you can access it. And what else you have it here? I mean, I don't have any closures right now, but as you can see, pretty much everything, all the functions that is available in global, including like SVG and all that stuff. We'll look at it later. Why? What are the different kinds? But ultimately, if you go to, it has a proto, and proto has some stuff, right? So that's how the whole thing works. Okay. Yeah. Any questions on this? All right. So okay. So yeah, we'll understand a little bit more as we go along. But I wanted you to understand the underscore proto as a creator. Now, if you look at, like, I when I started learning this, I always was interested in prototype inheritance, because that is kind of a root of everything in JavaScript. If you don't understand, a lot of people say, well, why do you want to even bother understanding prototype inheritance? And I would say this is like the fundamentals of JavaScript. If you don't understand it, you will always suffer, because even if you create a class, it it creates a prototype, and if you add a method to it, it adds to a prototype inheritance tree, right? So if you don't understand this, then you're not understanding JavaScript. So you should not move further without understanding the object-oriented prototype inheritance in nutshell, because JavaScript uses heavily, actually. Okay. Um, okay, let's see what else. Okay, so now let's move forward. Again, you can also have, let's say here, I can have a color. And I can do the same thing. This dot model equal to, color equal to color. Okay, and it would set the color to this. You can always obviously use default properties. So I can say it's always Toyota and is always a red or something like that, and that should work as well. So if I don't provide anything here, then you would get an object with those default properties. Also, you can do, let's see, you can add a method here. Remember, in a typical inheritance, the methods, classical inheritance, you have a constructor, right? So you have a class, and then you have a constructor. In JavaScript, we directly use constructors. It's like almost like a creating object from an object. And this is very flexible, actually. I can later on, I can add some, I can say something like this, right?
I have a doubt.
Sure.
So we are doing this dot model is equal to underscore model, right? So we are not declaring model anywhere. So how it is, actually, we take a Java, right? We will declare a variable in the class,
Mm-hmm.
in a class variable, and in constructor we will refer that like this dot, model is equal to, But where does this model is coming from? Front object.
Yeah. So in JavaScript, you don't. There is. We don't define. So because it's a very flexible language, um, you just define and assign a value at the same time. Okay. So there is no place to, as I said, usually in a class you have properties, and then you have a constructor where you set the initial properties, right? In JavaScript, you can just simply take the constructor, and it kind of behaves like a class, and you set some properties, and you can also do methods, right? So, also you can do things like that. So for example, I can take the car, and I can say, let's say if I don't put the color here, let's see if it works. I'm not sure. No, I think you don't work. There's a way to do it. Oh, sorry. For this one, for method, you can do it. I think methods you can do this way, but not for, not for properties. Let me figure out. So methods you can do something like this, like get car. Sorry, this get model. And then you can do did I say 10? Oh, sorry. Return.
In the line.
Oh, okay. Yeah, get model. All right, so you get a Toyota, right? But if I look at now the car, what is how it looks like? My car internally. So the get model is directly inside the car object now, my car object, right? It's not under its creator. So that is a difference. A property that you define internally is directly inside inside the class. I mean, inside the constructor, right? As you can see. And excuse me. So this is called, it works, but this is not recommended. You should not use this. The problem with this is, let's say if I create a new car, okay, and if I console log that as well, then I got two cars, and they both have model, which is fine. Each car should have its own model, but there's no need for this get model inside each car, right? It's kind of redundant. In Java, that is the case. When you create an object from a class, each object would have their own methods. And JavaScript decided that you don't need to do that. It should be coming from the car itself, the constructor itself, and so you don't need to do this. So they came up with prototype. So the way the prototype works is you don't add any methods, you just add all the properties here. And for methods, you would have to use car outside, and then you would say get model like this, equal to a function. And here you would say return this dot model. Okay, so now if I run this and look at it, so I have both cars, but they only carry model. It doesn't carry any get model. Even if I do stringify here, stringify, okay. You see, they both only have Toyota inside. They don't have the method itself. And that is because the object only carries its own properties, which can change, right? But the methods kind of stay the same. So there's no need to add the methods inside the constructor itself. So where does this go, right? All right, so let's look at it. So if I look at it, if I look at its constructor, hold on, its constructor would have this get model. Okay, but it used to be, I think they keep changing the way Chrome works, but it used to be directly, there should be like a prototype here, and then you would see get model here. But I believe now they have changed the way they show it. Now they show it inside here, and they put it inside here. Let me see. Do I see anywhere else? No, this is not. Don't go too deep because it's confusing. This is just a constructor of, and it's just confusing. So don't look at that. Yeah, I think it's just simply grabbing it from the constructor now. Yeah, it's confusing the way they do this. Initially, there used to be like a separate property called prototype here, but now they put it. It seems like they put it inside the well, constructor always had them because it is coming from constructor, but it's inside the constructor's prototype somehow.
Hemel,
Yeah.
my car and my other car, are they called instances of car?
Yes.
And my second question is there a way to see how many instances of a constructor are created in a window?
Yeah, you can actually. Well, there is no way in a JavaScript to do it. You have to have some sort of like a static. Um, yeah, you can create a counter. You can create a counter, right? And then that would kind of keep track of all the instances that are created. Uh, by default, there is no such method. Does Java has any method such method that I think you can do static method or something, right, in Java, where you can keep track of all the object that it creates.
Oh, not sure about Java, but I think I've seen manually keeping a track of the count of the number of instances that we create.
Oh,
I mean, in web development, sometimes we don't need another instance of a constructor. We just need one instance to do all the things.
Oh,
So I've seen manually keeping track of the objects.
Oh, okay. Okay. Yeah, I mean you can technically have some sort of a static variable that actually keeps track of every new car that is created. You can actually do it in a global as well if you want to. Um, so one way to do it is, I think, and this is a bad way, but let's just try it anyway. So
Spelling mistake on line 6.
oh yeah, thank you. I'm really bad at spelling. All right, let's see if it does. Oh, sorry, not window. Counter. Yeah, so it kept 2 here. Yes, that's how. You can do it inside also because I'm doing it globally because object itself doesn't. I'm trying to think if there is another way. I'm not sure. Let me know. I'll figure out if there is a different way of doing it. Because you need to have it globally so that whatever you created, um, you can create something better than this so that it runs a function and then it holds as a closure or something like that. Yeah. Okay. Okay, let's see what else. I think that's about it for the constructor. Let me see. Yeah. Okay, so here, let's recap this thing, right? First of all, you always have try to keep constructor name, capitalize it. Object name should not be capitalized so that visually you would understand it. Don't use this as an arrow function because of this problem, right? So if I use arrow function here, it would not work. Car is not a constructor. Yeah. So then it says car is not a constructor anymore because I use an arrow function. Then it becomes a pure function. So don't use an arrow function here. Second thing is always use methods outside as a prototype method. Oh, you know what? My bad. This should not be done this way. That's why you don't see it. That's why. I should have used this. I was like, why is it not showing up in the prototype? So this is how you should do it. car.prototype.get model. Now if I do this, it should show somewhere in the prototype. No, still not. I'm still, yeah, so inside the proto now it has this, yeah, again, this used to be inside, this used to be called like a prototype and then get model. Now it just show get model here inside the prototype. So what it does, let's understand this. So inside its creator, it has a constructor, which is this guy, and it would have all the methods here. Before you used to call prototype and inside there will be a like method, but now they changed it, put it directly inside it here. So yeah, my bad, I directly said, because if I just use directly, then it's like a part of the constructor as well. So if I have another method, it should go here as well. So let's say set model, for example. So now if I look at its proto, it should have two methods and a constructor. So basically it creates a space with constructor and whatever method you add inside, which you can access it when you extend this object. Okay. All right. Any question on this so far? So. All right. I would suggest do a lot of practice because the best way to do it is just practice a lot, understand what's going on, and then do it. Let me get some water. Hold on. I'm just getting thirsty today. All right, now let's come to the inheritance. So now we created a constructor, but how do we actually extend this constructor, right? So for that, let me remove the counter from here. So no space. Okay, I'm just going to remove them. So only have one method here. Okay, so now I have a car. And I want to create, let's say, electric car from it. Okay, but I want to extend all the car's functionality and create another constructor. Think of this way. Okay, so like in Java, where you have a class, and then you extend a class, where you would have all the classes. I mean, the parents class functionality available inside the derived class, right? Plus its own functionality. So we're gonna do the same thing here. All right. So let's create. So the way you would do it, you would create another class called, I would say, const. I'm gonna call it toy car. Okay. And it's a function. Okay. I'm just not gonna have anything inside here. Okay, I just want to simply inherit car's properties into toy car. Okay. So there is a special method called object.create. So all I have to do is, I would just say toy car dot prototype equal to object dot create car dot prototype. Okay, so let's understand this syntax in detail. So remember, object is the master object that it has all the methods. So if I just simply, let's say, console log object, the master object, and I should see this, I should say dir. So if you don't see its detail, you always do dir, and then you should see, and it should have a method called create. You see here, it has a method called create. So this is we are using, and what it does, it allows you to remember we looked at the prototype, which is inside its proto we have the constructor, and you have two methods. We had two methods like get model and set model, right? So what it does, it sets those into, not, it doesn't save it inside car prototype, but it actually sets a reference to that. So if I create my car using, let's say, toy car, okay, let's see what happens now. So now what I've done, I created a car, then I created another object called toy car, and I set its prototype reference to car's prototype reference. So I have access to all the car's prototype into my toy car's prototype. And then I'm creating two objects using this toy car. So now if I run this, instead of car, now it's both my car and other car are called toy cars, right? And it has a proto, but as you can see, its proto would be car's proto. Remember, we set the reference. So now I have get model inside the, so the get model still lives inside the car, which we inherited. So if I do here, let's say get model, which is true for both. I have to execute this. Hold on, what happened? Okay, so important thing to notice here, I'm getting undefined. Does anybody know why is it happening? Why I call this?
Because we didn't set the model to Toyota.
Yeah, but why? Because
it belongs to car and not toy car.
Yeah, so the constructor, remember, if I look at it, let's just look at my car. Okay, so the toy car, what happens? It has a constructor. So this is toy car's constructor, which does not have its own. It is not setting its. It cannot call. Remember, when you inherit things, you're not inheriting a constructor of your parent class, right? You inherit this method, which is fine, but you're not inheriting the constructor. So that is a confusing part. Okay, but we'll look at that in a minute. Let's keep going, and then let me not run this. What if I create another toy car? Let's say I call it Lego car, and I will set its prototype to object.create toy cars prototype. Okay, and then both my cars are actually Lego cars. Oh, I need to actually always need to define a constructor before you can inherit, because there is no Lego car, right? So I have to define a constructor. Okay. So now I have, it will always say car, because even toy cars prototype is car. And so it's also prototype is car, and then it has this object. So you see this is called prototype chain. Okay. Now let's do one thing. I'm going to add a method in here. So I can say toy car dot prototype dot get toy. What should be get price or something. Okay. And it doesn't do anything, just say return. This dot price. We don't have actually price here, but let's assume that there was a price here in the toy car. Now let's look at this. Okay, so I have a Lego car. It's in. Where's the, did I set it properly? Toy car dot prototype it.
Console log like my other car.
Oh, that is correct. So I am, oh yeah, this supposed to be toy car prototype is Lego car. No, that is correct. So I'm creating toy car from car and Lego car from toy car. So the Lego car should have get price. Okay, let me do this. Not the Lego car, let me do toy car. Why is it not? Oh, that is why. Okay, so that is another important thing to notice is when you inherit. Okay. When I made this toy car, so the order of your how you define things really matters. So let's understand this thing, right? So first part here is car. So I defined the car, set the prototype, then I created toy car, and if I do, what happens when I do toy car dot prototype dot get price here? It sets its prototype to be, so if I console log, let's say toy car here, do dir, then I should see the, in its prototype, I should, well, did I, that's too confusing. Where's the method? Toy car dot get price. Let me just do this here. Now it has a get price here. So let's understand step by step. When I do, so right now I haven't inherited anything from the car. So I have just a toy car and I just added some method, prototype method to it, right? I haven't inherited anything from the car yet. So that's why you see the get price. But as soon as I do this, as soon as I do this line, let's say if I put it here, this line actually wipes out toy car's prototype. What it does, it actually say, okay, my prototype should be car's prototype. So any methods you have, any prototype methods you have in the toy car, it goes away. So if you want to add it, you need to add it after you set it prototype. So any method you want to add to the toy car, it has to be done after you set its prototype. Okay. So now if I look at it, toy car, you have a get price and its parent I have get model. So I have both here. So that's what you need to do. Okay. So the order does matter. So first create it and then add it. Again, because JavaScript is very flexible, it doesn't have like a fixed class. In Java, you once you define a class, you cannot change its you cannot add a new property to it or anything like that. JavaScript, I can do it anytime, right? And that's why this is happening. Okay, so now let's continue here. So I added a prototype. Now I am creating a new Lego car. Okay, and then I would not need this here toy car because I already created over here. And then I would say Lego car prototype is this. And let's add some property to Lego car. Lego car dot prototype equal to prototype dot, let's say Lego size or something. Get Lego size. And this would be this dot okay, and we can add this Lego size here. All right, so this order is fine now. Now I'm gonna create my new car using Lego car, and then I can see what my car looks like. All right, so I have a Lego car. Again, there is a reason, as I said, why constructor doesn't work, but that's fine. We should not worry about it. I'll tell you later. But we just focus on the methods right now. So it has a get, its prototype has a get Lego car size. If I look at its prototype, it has get price. If I look at its prototype, it has get model. Okay. So this is called prototype chain. And I can access any of these methods from here, because by reference, the way it works is whenever I call a method, so let's say if I do mycar.getModel, what it does, it first looks at its own object. If it cannot find it, then it looks at up the prototype chain. If it finds it, it executes it. And if it finds it, it stops there. If it doesn't find it, it keeps going up the prototype chain until it finds it and execute it. So if I have a same method defined twice here, the very first one would get executed first, and then it would not go further down. So that's an important thing to notice. Okay. Any question? I know it's quite heavy subject, but any question on here? All right, looks like everybody got the concept. Okay, so does anybody know why this constructor is not working still? Because if you notice, yeah, go ahead. Who is that?
Is it the get price constructor? Sorry, get price method?
No. So the constructor, so that like a car has a constructor, right? Here, a toy car has its own constructor. Then Lego car has its own constructor. Okay. And when I run this, I don't see any of these constructor here. And that is, just fundamentally speaking, why it's happening is this. If I look at the car's prototype, let's forget about everything else. Car prototype, what it has get method and get model and constructor, right? So when I define a toy car initially, I started with the constructor, toy car constructor, which has a price and it's so this is my constructor, right? As soon as I do toy car prototype equal to object.create, what it does, it takes car's entire prototype and sets it here, but it doesn't have access to the car's constructor. Okay, so that's why it's happening, because it loses its own constructor. You don't see all the constructors here. It's kind of gone. Well, you could see it inside here, but that's kind of way somewhere, it's hidden somewhere, but it's not usable. It should be right here, right? So for Lego car, it should be get Lego size, and there should be a constructor here. Okay. Um, all right. So to remove all the complexity, I would just simply keep two levels so that we can understand. I would just remove the Lego car and just keep toy car here. Okay. And in order to get the constructor back, there is a method. We already know. Do you know call, apply, and bind?
We bind this to have the context dot bind, and we pass this.
No, but I mean, do
Not
we?
in detail.
Oh, okay. I know we haven't covered it. Okay. But there is a. How do I do this? Let me see. There are three methods called call, apply, and bind. Let's understand that first, so that we can. So let me open another JS fiddle here. And we not learned this, but I think in order to understand the constructor, we need to understand that call, apply, and bind. But I'm just gonna go kind of shallow, and then when we understand the functional programming, I'll show you more. So let's say if I have a function here, add equal to, let's say, function. Okay. Inside I can do like this dot so how do I do this? Let's say if there's an object. Okay. Let's say you have some object, well, which has property A. And you have some method called add, and what it would do would just simply say this dot A plus B. Okay. Now the problem here is, let's just do return. Now remember, as I said, we only pure functions basically uses arguments that you supply, and it returns something. And if you have a constructor, then you can use this and set something, right? Here it's kind of weird. It says this dot A. We haven't set A here. And that is because, let's say if this is somebody else's object which has a, and I want to use it on something else. So what I can do is I can say add dot, so take the method call let me check what the right syntax is. Script call. Man, it's a prototype method. Yeah, you can see here product, call this. Okay, let's look at this one right here. It's a little bit better. So you have a one constructor, right, called product, and it has a name and price, and it's setting it like this. And then you have another constructor called food, which has a name and a price. So I can call product and set this plus so almost like do you know in a class you have super? So this is similar to super. So it's saying, set my parents, call my parents constructor in a way from this constructor. Okay. So we can use a similar functionality here in the toy car. So we have this price.price, and we can use the same thing here. But instead of product, we can call car. Okay. Since we're not providing any, we already have a default, I'm just going to use this. Otherwise, you have to provide the model name here. Okay, but I'm just going to use this. So what it's going to do is, for the toy car, it's going to call car's constructor and set the model equal to Toyota. So this one would be like model equal to Toyota and price equal to price. Okay. Let's do one thing actually to remove the confusion. If I run it like this, get model is not a function. Yeah, because I haven't inherited anything, so I'm just gonna do this. So now toy car has model and price is undefined. Well, that is because I haven't provided the price yet. So let's say price is 10 or something. Now I have model Toyota, price is 10. Okay. So let's try to understand this. So you have a car. Why there's a counter here? You have a car. You have a method for car. You create a toy car, and then you call car.call this. What it does, it calls this constructor. It's almost like super, and then sets Toyota equal to Toyota. Okay. Let's say if I want to do Nissan, I can do this. So instead of Toyota, it will be Nissan. And if I run this, I get Nissan for this toy car. Okay. Again, I haven't really inherited car's prototype yet. I'll do it in a minute. But just to see From one constructor, I'm calling another constructor to set its property. I still don't have access to here. Remember, I removed that object.create part. But as soon as if I set the toy car dot prototype equal to object dot create car dot prototype, then what happens? The constructor gets wiped out.
I think your screen froze and everything appeared just.
Oh really? Okay, hold on a second.
No, it's working.
It's working. Okay, sorry. Okay, so
car.call, how many arguments can it take, and what exactly is happening there inside the call?
So call is basically you can have one object. So basically it's almost like saying, okay, I have a car, which is a function, right? I want to use this, which is inside of, what is this for this object? Means this here means toy car, right? So it's saying that run this, but set use, instead of using cars this, use this for toy car, right? So here I have car is basically outside, but use car on toy car, as if I'm setting model into toy car. That's all it means. And the second part is whatever argument I need to pass to run the constructor, I will pass after this. So if there was like 3 arguments here in the car function, I would have to pass 3 arguments here. If I don't pass anything, then as if I'm just running, like if I'm running, for example, car like this, then I only have to call it car call this. But if I'm passing 5 arguments, then I would, do 5 arguments here. Got it? It's a little bit confusing, but basically it runs it and runs this car, but instead of this dot model equal to model would be setting here. This dot model equal to Nissan here. So this line basically nothing but this dot model equal to Nissan. That's what it's doing. So it's running this function, but on scope of toy car. It's almost like remember in a Java we have super, right? It does the same thing here. And call is a very, very important function if you use a functional JavaScript, we'll look at it later in detail, call, apply, and bind. This theme function is like fundamentals of all the functional JavaScript. So we need to understand this in more detail, but think of this way. You're borrowing function from outside scope, and you are executing on the scope of toy car. All right, so that's what it's doing. Anybody's got any question? All right, so okay, so now that I've done this, let me remove this guy here. Oh yeah, so remember here I was trying to do the same thing here. If I do, I think it was something like this. So think of this way. I have an object here where a equal to 1, right? And I have a method which says this dot a. Now this function, this does not have a at all, right? You don't see a at any. I'm just passing b here. So if I want to use this object's a as if it's part of this, I would simply do this: add, call, use this object, and an argument I'm passing this. It's kind of weird, but that's what it's doing. And then when I run it, I would get 3, which means 1 plus 2. So in a nutshell, this is how a call function works. And this is how also bind works. We'll look at it when we look at call, apply, and bind, but this is actually how bind works. You basically, this is like a mixing two things, right? I'm using somebody else's property and calling it mine, as if it's mine. So that's what's happening here. Okay. And again, in this case, you need a little bit more practice. You need to run a few examples, and then just understand it. I think you would not simply get it by just looking at examples. Okay. All right. So when I did this now, it works. Now it has this constructor, and it's setting the price, Nissan and a 10, both here. Okay. When I do toy car. So that's how the constructor is working here. Okay. Any question on here? This is very important. And I think there's a last step, which I believe it's something like this. You have to, here you don't see the constructor of, anywhere you don't see the constructor of this guy, right? Toy car, because it wipes out. Like for a car, I have a method and a constructor. For toy car, I don't see that. So I can set it here. I can, again, after this, I can say toy car dot prototype dot constructor equal to toy car. I think it's this syntax. Let me see. Yeah, now it sets the constructor back inside. You see now it has toy car has a constructor and its prototype, and a proto has this. So this is car has a model and its own constructor, which is Toyota. So now our inheritance completed, where I have, toy car and I'm creating from car, and I'm inheriting its methods and its all am executing its constructor like super. I know it's quite heavy, that's why it took a little bit longer, but I wanted to actually go deeper and try to explain how all of this works. You can easily, if you want to ever crack an interview, if you ever want to confuse anybody on an interview, just give this example. I would say mostly maybe 10% of the people can figure this, will be able to understand. So if you just say, okay, I want to have a car constructor and I want you to inherit toy car and I want you to have its own property and its own constructor. How do you do that? And a lot of people would be confused. All right. Yeah, today I wanted to spend more time on this today, but should we go through classes or should we go continue on the classes, or you guys want to? I also wanted to do. Um, Remember, I said we can move to create a React project where either you want to keep your current project as it is and create a separate project, separate React project where you can apply all this stuff that we learned, or you just transfer your original project to a React project. Okay, so I wanted to go to CSS, but I think we probably uh, can do one thing in CSS, and then I can show you a little bit about how to do the React project. Which one would you prefer?
React.
Okay. All right. So I would say let's just do React. And if I have some time, then I wanted to show you Z index. And then next session we'll do more CSS centric. Okay. All right. All right. So for React, I mean, so from three of you, um, I remember one of you have done React, right? Or some React at least. I couldn't hear you. What did you say in there?
I didn't work on React.
Oh, okay. What about Rama?
No, no.
No. Okay. And Sesha?
I didn't work on React.
Okay. All right. So let's start. Let's start here. You guys know Visual Code? VS Code?
Yes, sir. Yes.
All right. You guys use it? I think it's pretty cool. I use it all the time. It's pretty nice. All right. So let me first do one thing. Okay. Everybody's comfortable with command line?
Yes, sir.
Okay. Good. Yeah, because it's important nowadays to, have good command line grasp, right? So in order to start React, you need to install a package. And that package is, let me show you, called Create React App. Okay, so this is the package that you need to do, and you can use npm, or they're calling now npx, which is like a later version of npm, or you can use yarn as well. Um, I'm just gonna use npm, but I have a version called nvm install nvm ls. So nvm is basically called Node version manager. So I can have multiple versions of Node on my computer. And what I can do is I can switch between. So let's say if I'm doing multiple projects where I need multiple Node versions. So one project only works on, let's say 6.11, then I can use that, or I need 8 point something. So I can switch back and forth. Otherwise, it becomes very difficult. So I would highly recommend using NVM. And you can find out if you go Google NVM, you can find out and install it, and then it has few commands. So one of the command is nvmls, which shows you all the Node version installed on your computer. Also, it shows you all the stable versions available. So like, for example, LTS is called latest stable. I forgot exactly what it is, but basically it's a stable version. And as you can see, that 4.8.7 was one of the stable versions. 6. So anything in between, don't try to use it. So I'm going to use 8.9.3. So I would say nvm install. Well, actually, at work I use n.9.4, which is a newer stable. So I'm just going to use that actually. And so if I do nvm ls now, it says now using, you see the green, which means it's using this version 8.9.4. Okay. I guess now it's updated, so the new stable version is actually 8.10, but that's fine. I'll just use the 8.9.4. Okay. Now let me do clear. Now what I want to do is I want to install that create React app. Now what happens when you have a package, right? There are two kinds of package that you can install. There's a global package and there's a local package. Do you guys know what's the difference between global package? Which one is a global package? Which one is a local package?
The one in dev dependencies is local.
No, that's a different thing. Dev dependency is for development purpose. Well, it's things that you require to develop things.
Icon G.
Yes. So global, yes, you would use using -g. But the reason you would install something globally is, so let's say if I want to install React, right? Now React, I'm gonna be using, whenever I create a new React project, I would be needing React, right? So I don't need to install create React app. So create React app, what it does, it actually install a package which has ability to build new projects of React, right? So I need to install that only once, and then whenever I run it, it should create a new React project, right? So I need to install it globally because I'm going to be using, it's almost like a constructor, right? You have a constructor which creates multiple instances of produces multiple instances similar to this. So create React app, which is a package that basically allows you to build projects. So you need to understand that that needs to be installed globally, and we'll see where it installs. So you would do npm install create React app, and in the end you would say .g, means I want to install this globally. Okay, and you could see where it installed. It installed inside wherever your node is installed, it's installed there. So every global package will be part of the version of node that you have installed. So I have 8.9.4 node version, right? So it installs inside that node 8.9.lib, and all the packages you install globally would go there. So let's say if I change a version of node, then I would have to install it again, because this version is only available inside there, right? So always remember that. A lot of time that is a problem. Okay, so now I can use this create React app package to create a new app. So all I have to do is create React app, and I'm just gonna give a name of my app. So I'm just gonna say this app or something, okay, or my first app. All right, now it doesn't like this name because you cannot have capital letters here. If you use it Angular, it will do it. So here I have to do this way. Okay. Oh, sorry. So this is almost like a CLI for React command line interface, but it doesn't have like a lot of functionality. It has some. Now this usually takes about half a minute because it has to grab all the dependencies and sub-dependencies and all that stuff onto here to actually and then it actually builds the whole tree of dependencies, and those different packages might live at different locations. So that's what it's doing. All right, so let's do one thing. So now I'm just gonna open the Visual Code. Does anybody know how to do it open it from the command line? Visual Code from command line.
Maybe you can set an alias.
What is it? What is this?
You can just set an alias, so you can just
Alias. Okay. Yeah, I can use the alias. But in the Atom, there's a simple way of doing it. To say, you would simply say.
Yeah, I use like code dot space dot for Visual Code.
Oh, okay. Okay, so let's see, where did I create this? React. My first All right, so let's understand what's inside here. Um, so how familiar are you guys with the package.json?
Moderately familiar.
Moderately, okay. I think I think you guys should spend a little bit more time. I mean, if you want to do any modern kind of projects, even testing or anything, I think nowadays all the JavaScript frameworks, or even if you do like a raw JavaScript, you have to use some sort of dependencies, and then you have to use a packager, right? So you need to get used to understanding it. So first thing you would see is the name of the project version, and then it's private, right? Because if I upload it on the Git, I would have to. It will make it a public package. Um, then I have a dependencies, right? So because I created using create React app, it added 3 dependencies already inside. The main React package, React DOM, and a script. And then it's using if you this and then this script. So the scripts are something you can use directly from command line. So for example, let's say if I want to use start. So this start would allow you to actually compile the project and open it for me. And it's saying that it will call this React script start, which you can see, which is here, right? React script. So it will go to one of the dependencies and start. Now, where are the dependencies? The dependencies are installed in the node module. So every project would have a folder called node module, and it will have like bunch of stuff. It's because each thing would have its own dependencies and all that stuff. So let's look at the React scripts. Okay, so I have React scripts here, and I can see the scripts here, and then this is the start.js. If I want to look at it, I mean, nowadays I can look at anything if I want, right? And you can see how it's built. Okay. So that is if you want to know more about it. You have it everything here, and that's wonderful. All right, so let's go back here. Okay. Okay, so then build is when you start, it also built it builds the project, but build specifically builds for where you really want to use this project as in a production environment. Test runs a test, so it actually built in test. Eject is usually you don't see much thing. It usually actually use a Webpack to build the project, right? But does anybody know Webpack or familiar with it?
I know it's a module bundler, but I didn't really work on it. It's there in the projects that I work on.
Oh, okay. Okay. Yeah, I think it's very important to understand Webpack these days, because if you if you so by default what happens? React gives you like a visibility. Here you don't see much configuration, right? But if I eject the project, then you would see all the Webpack related stuff, which is very important to understand, because you might want to go and manually reconfigure something, right? Which you cannot do it right now, because it's everything is hidden to you. Okay, so eject would eject your project and expose all the Webpack configuration for you. The only thing is, once you eject it, you cannot go back to this normal project. which is fine. A lot of time you want to do that because you want more flexibility on your project. You want to be able to change things, right? Then all your code would live inside the source folder. And then your public folder will just basically your index or HTML. You will never modify this thing. Everything that you want to do, you should do it from the source folder, which basically, because nowadays, when you build your project, it basically bundles everything for you, and all the dynamic part is actually inside the source folder. Even if you want to add some CSS or something, it's taken care. You don't have to ever change index or HTML. Okay. Okay, let's look at this. This is your main part. There is an index.js. This is your main starting point in your project. If you look at it, it's importing React from React. So when you import something, it already know that it's doing it from your node module. Okay, so it doesn't need to actually understand what is. And if I look at, where is that? If I hover over it, you can see where the module is located, right? This is nice about VS Code. It shows you where things are located. Okay, so it's a node module, React, index, it has some CSS, but I would suggest React uses more like a inline CSS. We'll look at that later, but just to let you know. Then it imports this component called app. Now this is the main component, and what it does here is that React DOM, which is using the React DOM, it renders app component into your root element. And if I go back to the index or HTML, I would see some root element somewhere. Do I have a root element here somewhere? Right here. It has ID root, right? So what it does is, because you need a starting point, so it has one element which has an ID called root, and it attaches the app component. So app component, your entire application starts with an app component. So app component gets attached to this root element, and all your other component would live inside the app component. So here's the main app component. Now let's compile this project. So in a VS Code, I think you can do integrated terminal. So if I simply do, remember all those scripts here, npm, I can simply do npm start. Okay, which we looked at that script start, right? If I do that, it will compile the project and bundle it and everything. And it opens by default on this port 3000. And it has this logo, some text, and this, right? Now let's remove all of that. If I save it, and then I just have a div, and I'm just gonna say my project. If I save it, now I get to see my project. So this is how you can modify your project. Now let's understand what's inside the app.js. Let me close every other stuff. So this is my main component that's get loaded when the application loads, right? There's a logo. I don't need logo. So it has two things, React, and it grabs React and component from React library. And it has some initial CSS, which is in the same folder, I think app.css. And this is the most important thing, class app extends component. Remember we looked at the syntax on constructor and extending. It's actually underneath is doing the same thing. So it has some component class and it extends, it has all the functionality that component has into here, and it uses the prototype inheritance. So it doesn't really copy all the functionality, it just provides a reference to app so that it has all the functionality available. Okay. And inside this class, you usually have this one main method called render. What render does, it render me some DOM, and you have to return it. You have to return some DOM. This looks like an HTML, but it's not HTML. It's called JSX. And JSX is basically means JSX. It means JavaScript XML. Kind of weird name, but it's actually really, really good. So 90% of it, I mean, pretty much it's all HTML, except there are some caveats that you need to understand. It's not 100% HTML. It has some little different things, but mostly it's HTML. But what it does, it actually React is, it's all JavaScript. It does not have any, like in other languages you have templates, which is like HTML templates, and then you have some JavaScript. In React, everything is JavaScript. Even though it looks like HTML here, it's actually JavaScript. In order to see it, let me go to Apple React. And that's the beauty of React. Let's say if I have a simple div, I would just say hi inside, right? And on this side, it would actually convert into like a React object. So this is actually what it does. When you write this, it creates an object like this. Let's understand this. So it creates an element with three things in it. The first thing is the name of the element, which is div. The second thing is if there is any property that I'm passing. I'm not passing any attributes here, so that's why it's null. And then the third thing is called children. Does this element have any children? Nothing, right? Oh, it has just a hi text. Let's say if I pass some property here, call my prop or something, equal to, you have to pass it. If I want to pass something, I have to use curly brackets, and inside I would say, if I want to pass string, right? Hello. Then you can see here, I pass this hello. I can have some more, some prop equal to, if I want to use Boolean, then I would just say true. And then it kind of passes two properties. Okay. I can actually have another div inside. and now the children is replaced by another element. So every element is basically React. So originally when the React came out, they used to write like this, but now they have JSX, so much easier to write. So this is part of, you need to understand that this right here, it's nothing but, so if I copy this, it actually creates something like this. So the difference, as I remember, I said there's a difference between HTML and the JSX. HTML, you have classes, like class or ID, right? I cannot use class because it conflicts with the class keyword that you have. Remember, we have this class here, so we cannot use class here. So that's the main thing. You have to use class name if I want to give it a class. And if I want to see exactly what happens, I gave a class name equal to app, right? So now when I compile it, if I look at it here, it says class app, as you can see. So this class name became class inside. So that's the only difference I would. There's another one, I forgot, but yeah. You can also have like in the HTML, you can have like a break. This is a valid break in HTML, right? But it would break the React because you have to have opening and closing. So otherwise I have to do this, right? I think I can do this now. Oh, not here, sorry. Another thing is, in every component, there should be only one parent, and you need to put everything inside. So now this should work. So you only should have one. There's a way around it, but you should only have one parent. So far, any questions? I know we covered a lot of things, but I'm gonna post this video so you can practice it on your own once. The only thing is this is a usually much larger video, so sometime when I upload it on YouTube, it takes few tries because it sometimes doesn't like it and it fails in between. So it takes me at least few hours to actually export this video and upload it on the YouTube. So I'll try to upload it by end of this day today. So hopefully you can start looking at it. Okay. All right. So now let's create our first class, and then so you at least get understanding of how it works, right? And then we can stop. So I have this app class here, right? Which has this JSX. Now I can create my own class. So all I have to do is, if I just copy this thing and up here, I'm just gonna say my component, my comp, okay? And inside here, I would just have simple div. It should say my comp. I don't need this class. Okay. Now I can use this class component here inside. So instead of my project, what I'm going to do is I'm going to use this my component. And remember this, I can use this as a tag. So now if it automatically compiles, so you can see it's my component here. I use it multiple times, so the concept of creating once and using it any times works fine. I can pass some properties here. So let's say I want to pass, let's say some property called my prop. And you won't always need to pass. Remember, we looked at you need to pass it within a curly bracket. So I'm just gonna say 1. I'm passing a number, and each one of these I'm gonna pass a different property. And here I'm gonna say 2. This one be 3, and this one be 4. So now the property comes here, but how do I actually write this property inside here? So whenever you pass something inside, all these properties are accessible inside this component using a property called props. So I can do this dot props, and I have this my props available. So any property that I pass in, it's available within this object called this dot props. Okay, so it automatically passes into my component, and it's available here. So now if I save this, I should see 1, 2, 3, 4, right? So this is how simple React is. Now, besides this, you can now I would say, I mean, this is just the one example of how to do it. We can go much deeper, and the beauty of React is because it's all JavaScript. From this point, if I want to do something, I have to use JavaScript to do it. And it doesn't have, as you can see, it doesn't have really anything fancy. Like if you use Angular to do this, you will have like 5 different concepts that you have to learn and all that stuff. React is like really easy. And you can apply pretty much all the concepts we learned here. I mean, we haven't applied them yet because I just want you to understand the basics of it, right? And this should be a good point to stop, so that you should be able to create your own project, create your own component, and pass the properties. And then we'll look at it, how to build this project on the top of it. This would be, at least you learned today, I would say 20% of the React. If you can do this much, you already know 20% of the React, I would say. Okay, it's this simple. That's why a lot of people are going to React, because it's so simple and you can use all your JavaScript skills that you learned without using any kind of fancy methods. Like if you go to Angular, if I want to use this property, you have to have a decorator, input decorator or something, and it's a lot of work. Here I have simple. Like let's say if I have, instead of a number, if I have an array, if I pass an array, right? And here all I have to do is I want to print the entire array here. So what I'll do, I'll use pure JavaScript. I would say this dot props dot, I can use a map function. Okay, and what map function is this is pure JavaScript, right? It has, you take each element, so I would say each element, and I can display each element however I like. So I would just say return okay, that's all I have.
Can
I had
you
to
use
use
for
it.
each is the map?
I actually okay. Actually, I need to use here. Hold on, I think. Mm, oh, what is the error? Usually the error is should be inside here. You cannot use for each. That's why I'm saying you need to use all the latest. I think it's. I'm not sure why is it not working. Something is. Let's see. Did I make any mistake here? Uh, this dot props dot map element. This inside I have this returning the element. Okay, let me just look at it. Yeah, you should simply. Yeah, you could simply do. You don't even have to. You can simply do this, I think. Or even I think this. Let me see somewhere. Give me an example. Oh, here they have done something like this. But that should not be needed. Maybe something else is wrong here. I'm not sure. Okay, so oh, this dot props dot map. Oh, that's why. I forgot even the name of the element. That's why I should say this dot props dot my prop dot map. That's why I was like, why is it not happening? Okay, so here I can simply do this. I don't really need. Uh, right. Uh, yeah, and you can obviously add some li or something. It would work as well. But yeah, so in React you probably need to use so try not to use for loops inside. Um, I think a lot of time for loop there are places where you can use it, but you probably want to use all the functional programming concepts like map. You want to use arrow functions. You want to use spread operators, object or assign, all of these stuff, right? Um, and that's the beauty of it, of React, that you would get to use all the complex concept you're gonna learn, like bind, um, things like that, right? Here, and That's why I wanted to create one. CSS is also interesting in here. We're gonna do that later on. We're coming to the end, so if you have any questions, but CSS is also very simple. Um, yeah, I mean, you can pretty much, as I said, you can pretty much learn React in a 1 month if you are dedicated, you know, and you can become really good at it. It's it's that simple. Okay. Um, yeah. Any questions so far?
Yeah, how to handle events between two components.
Um, yeah, events are.
For a child component is an event. How a parent will catch the event and give the data
Yeah,
up and actions up and data down.
yeah. So, okay, let's do that. So, let's say if there's an event here. Okay. Um, let's say if there's a button here. Click me. Okay. And it has some on-click event. And you always do this, right? And when you do on-click, you need to use some sort of handle here. So I would just say from parent. Okay. So if it's happening inside the component, lower component, you don't define inside the lower level component. Instead, you would define it outside this component on a top level component. So I would define this guy here. So I would say my parent equal to, okay, and I will just simply say console log something, right? Clicked or something. And then what I can do, I can pass this event inside here. So I would say my parent equal to this dot my parent from parent. What did I say? From parent? Oh, okay, from parent equal to. You need to map it properly. We'll look at that in the next one, but I just want you to, for some of you, probably this is too fast. So basically what you do is from a parent component, you create an event. Even though event is happening inside the child component, you define it in the parent component and then pass that handle. So when the child clicks on it, it would be this dot props. Remember, I'm passing it as a prop here, right? So if I want to access this, I would have to, inside here, I have to say this dot props are from parent, right? Okay, so let's see if it works. Okay, there's some issue. Button can be, oh, yeah, again, remember I said it has to be in a single. I cannot do it like this. I have to be in, it has to be inside this div. If I do click here, click me, it should say clicked or something. So it says clicked, right? Does it answer your question?
Yes.
Yeah. So basically, the lower component, you just have an event, and then tell parent to execute it. So you just say some property of parent, please execute this, and then the parent, what it does, it takes it builds the method and passes into as a property. Okay, so that's how you do it. And there's more to it. We'll look at it in a next. Maybe from now on, maybe we'll spend like half hour every. I want to do good hours so that we understand exactly, you know, what's going on. But from now on, we can do one concept. So let's say if we learned something, map function, we'll use it here. Um, because you can use all kind of nice concepts, um, you know, so it would be very helpful. Yeah. And then because it's a component based architecture, see the problem with the if you build something in a raw JavaScript, if you can build a library in a raw JavaScript and it's fine, like Rama is doing, right? But if you want to build an application in a raw JavaScript, it almost like impossible in this day and age, because you have to, any change would be like you need like a team to do it, right? Library, small library you can manage, but when you have like a UI component and everything, it becomes very difficult. That's why I want you to use some sort of framework where you can apply these skills. And React is probably the most simplest one out there. I heard Vue.js is also much easier, but I haven't done much Vue.js. I know React, Angular, and Ember very well. So, but from all three, I would prefer React because it's the simplest one. Um, so yeah. So as for the homework, I'll send it out. But what we need to do is um, the previous app that you built. Think of how you can either do a parallel project where you build the same functionality in React, and see how far you can go with both, right? If I have to do something in React and something in a pure JavaScript HTML project, how difficult that becomes, right? Uh, so you can convert that into a React project, and then maybe let it go once it becomes too complex. The other project, just complete doing in React. Um, yeah. So, and you can email me or something if you get stuck on this, because um, it would require some practice at least. It's easy, but I would say more you practice on this, more it becomes like, I know Angular very well, but if I ask you to do the same thing in Angular, say, hey, can you pass me, can I, how do I do that, data down action up thing in in Angular, I have to like go refer three different web pages to find that out, because it's a little bit complex. In React, I can just do it in my sleep because it doesn't use anything fancy, right? So, any questions? All right. So for the next time, what I want to do is I want to see, in the object oriented part, we still have to cover classes. So I would go through that classes, and if you have time, I'll go to the call, apply, and bind thing, which I think is more important. And then we'll focus more on CSS next time, especially um, I'll do z-index, and also we can look at Sass, um, and then we'll spend maybe last half hour working on the React. Okay, and just adding to it so that you get some exposure to it. Okay. Um, all right. So any questions?
Hi, Hemo.
Yeah.
Regarding the project, did you also like skip the table and use Flexbox instead of table?
Not the flex. You can use Flexbox if you want, but I would suggest instead of using like a table tag, if you can use um, blocks and inline blocks,
Okay.
because if you if you can do that with the blocks and inline blocks, because table is very simple, right? Because what happens, table has its tr td tags and everything nicely aligned and everything, but you don't get much flexibility if you use uh, display property to um, scale that, and then for the text, remember you have to center it using the method I showed you, line height and um, what was that, text align center, right? So
Right.
that will be critical, so always center it, and then yeah, see if you can, see if you can do, we're going to discuss in next tutorial, but that is very important so that you get practice of using display property very well, and then you can learn while you do it. Yeah.
Okay. Thank you.
Okay. Any other questions? I know it was a heavy subject today, of object oriented, but I would suggest do more practice, because if you don't practice, this concept will just go out of your brain within a few days. It's like you never learn anything. Okay. So I would just say at least practice 2-3 hours a week, um, and yeah, and look at the console to see how the prototype inheritance work. Um, Once you get used to the syntax, then it's you know for me, it took me, that concept was so difficult initially, and there is no good documentation available. If you find on a web, it's like, and it's changing constantly, right? Because before you used to call something else, and then Chrome also changes constantly, and so you have to keep up with it, right? So all the old uh, blogs you see, is they're kind of useless. um, so the best thing is to practice and see for yourself, and if you have any questions, um, you know feel free to ask me. I would suggest at least do the car example for the object oriented part. Do it by yourself. Create an object, create a constructor, add a method, add a prototype method, extend it to create another constructor, call the parents constructor from the other, and then also add another method to it, and then see how it works. Okay. Yeah, I wish there was a way to actually, like, if you're in a classroom, you stop and you say, hey, practice, and I can go around and see everybody's work. That would be a cool thing to do. But since we have a limited time, I would suggest that you can ask me questions via email or the classroom, right? Somehow classroom, I noticed that when you submit the homework, I get the email, but cl- when you ask a question, also email me that you've asked some question, and then I'll look at it. Sometimes it doesn't really, because if it's a longer thread, it doesn't send all the emails. Okay, so you can ping me there, and then I'll check it if you have any questions. All right, guys. So, any last comment, thoughts? All right. So, seems like everybody got what I taught today. All right. All right, then have a good weekend, guys. And try to relax.
Thanks, sir.
Yeah. All right. Bye.